This section includes infinite limits from the left and infinite limits from the right and vertical asymptotes. What is infinite limit? A limit in which f of x increases without bound as x approaches c from the right. Mathematically, we write this limit x arrow c plus f of x equal to infinity as. You can see, look at the picture. If you move from the right and moving towards c, the graph is going what? So it's increasing without bounds. So that's infinite limit. Now, or f of x decreases without bound, just like in this picture. As you move from the left towards c on x-axis, the graph is going downward, decreases. And we write mathematically limit x arrow c negative of f of x, and this is minus infinity. So both of these called infinite limit. Example 1. So let's determine whether f of x equal to 1 over x minus 4 approaches infinity or minus infinity as x approaches 4 on the left, and b f of x approaches infinity or minus infinity as x approaches 4 from the right. So look at the picture. As x approaches 4 from the left, so that's in the left, so this is 4 here, and we're going this way, and you can see the graph is going downward. So the answer would be the f of x approaches minus infinity. So the answer minus infinity. Now b as x approaches 4. So you come from right and move towards 4, and the graph is going upward. So in this case, the answer would be what? Infinity or plus infinity. Vertical asymptotes. What is vertical asymptote? A line x equal to c is a vertical asymptote if f of x approaches minus infinity or plus infinity as x approaches c, either from the left or from the right. Actually, how do you find the vertical asymptote for a rational function in calculus? So first step is that you set the denominator q of x equal to 0 to find the discontinuities. So once you find the discontinuities, then substitute each discontinuity or x value in the numerator p of x. If p of x not equal to 0, then the discontinuity is a vertical asymptote and is also a non-removable discontinuity. And if you substitute x value in p of x and become 0, then we have a 0 over 0 situation, and we can solve the if we can factor out and simplify and find the limit at the discontinuity. If limit exists, then it is a removable discontinuity and is not a vertical asymptote. So let's do example 2. Find the vertical asymptotes. So we set the denominator to 0, which is q of x. Let's see, x minus 4 square equals 0. And then we solve. In this case, we take the square root of both sides. So you get x minus 4 equals 0, and then it becomes x equal to 4. Now we substitute x equal to 4 in this equation. I mean, numerator p of x equal to minus 1. Since this is a constant, so p of 4 stays minus 1. And this is not equal to 0, so therefore x equal to 4 is a vertical asymptote. Example 3. Find the vertical asymptote. So we set p of x is x squared plus 1, q of x is x squared minus 1. So we set the q of x to 0. Okay, so we can factor out. So it becomes x minus 1, x plus 1 equal to 0. We set x minus 1 to 0 and solve. We get x equal to 1. We set x plus 1 equal to 0 and we get x equal to minus 1. So now we're going to check if x equal to 1 is a vertical asymptote. So what we do, we substitute x equal to 1 in the numerator. So we get p of 1 square plus 1 equal to 2, which is not equal to 0. So therefore we'll say x minus 1 is a vertical asymptote. Now we check if x minus 1 is a vertical asymptote. So we substitute in the numerator p of x equal to x squared plus 1. So it becomes p of minus 1 squared plus 1, says 1 plus 1, 2, again not equal to 0. So x equal to minus 1 is also a vertical asymptote. Find the vertical asymptote, if any, of this graph. So we set the numerator is x squared minus 1 and the q of x is x squared plus 1. We set x squared plus 1 equal to 0. Now we isolate x squared and become negative 1, and then we take the square root. So we get x equal to plus minus square root of minus, which is plus minus I. Since plus minus y are not real numbers, so there are no real numbers for which q of x equals 0. So we stop here and we say no vertical asymptotes. Example 5. Let's determine whether the graph of the function has a vertical asymptote or removable discontinuity at x equal to minus 1. So here's the function f of x equal to x squared minus 1 over x plus 1. All I have to do is just take the limit of this function at x equal to minus 1. Okay, so limit, we write this as limit x arrow minus 1, x squared minus 1 over x plus 1. So we do direct substitution. So it becomes negative 1 squared minus 1 over minus 1 plus 1. So minus 1 squared is 1. So minus 1 and minus 1 plus 1 becomes 0. So this is also 0. So we have 0 over 0. So we simplify, factor and simplify. So what are the factors of x squared minus 1? Well, those are x plus 1, x minus 1. And x plus 1 is not factorable. Now you can cancel out these x plus 1s and you have a limit x arrow minus 1, x minus 1. Do direct substitution again. So this x becomes negative 1, you have a negative 1, so become negative 2. And this is a real number. So therefore we'll say limit exists, and we also say removal discontinuity at x equal to minus 1. So let's determine whether the graph of the function has a vertical asymptote or removable discontinuity at x equal to minus 1. So here is the function f of x equal to x squared minus 2x minus 8 over x plus 1. All I have to do is just take the limit. So we write limit x arrow minus 1, x squared minus 2x minus 8 over x plus 1. So to find limit, we just substitute, direct substitution. So replace x with negative 1, so we have a negative 1 squared minus 2 times x replaced with minus 1. And write minus 8 over, replace the x with minus 1, so minus 1 plus 1. So simplify it, so my negative 1 squared will be 1, negative 2 times negative 1 will be 2, minus 8, and negative 1 plus 1 will be 0. Now I say 1 plus 2 is 3, 3 minus 8 is negative 5. So we have a negative 5 over 0, so that would be what? It's not a real number, it's minus infinity. So we'll say limit does not exist at x equal to minus 1. So in this case, x equal to minus 1 is a vertical asymptote. Okay, here we have to find the limit if it exists. So it's the limit x arrow minus 3 from the left. You basically say you approach minus 3 from the left. And the function is x plus 3 over x squared plus x minus 6. So let's write down limit x arrow minus 3 from the left, x plus 3 over x squared plus x minus 6. So let's do direct substitution. And you get negative 3 plus 3. And this becomes negative 3 squared, negative 3 minus 6. So negative 3 plus 3 is 0, and this shall be plus 9 minus 3 would be 6, 6 minus 6, 0. So you have a 0 over 0, which is indeterminate form, so that means we can factor and simplify. While x plus 3 is already in prime form, this case we can factor x squared plus x minus 6. So I think factors are x plus 3x minus. You can see x plus 3 cancel out. And we have limit x approaches minus 3 from left over x minus 2. So you substitute negative 3 with the x's, and you have 1 over negative 3 minus 2. So which will be negative 1 over 5. So let's find one-sided limit if it exists. Limit x arrow 2 plus x over x minus 2. So we write limit x arrow 2 plus x over x minus 2. So we substitute 2 here and 2 here, so become 2 over 2 minus 2. So the 2 minus 2 is 0, so it becomes 2 over 0, and that's undefined because we cannot divide a number by a 0. So now we have to decide if the answer is minus infinity or plus infinity. So let's find out what this means, x arrow 2 plus. It means x approaches 2 from the right. And this means x is always bigger than 2. So we substitute a number slightly higher than 2, like maybe 2.0001, whatever we like. So let's do that again. Limit x arrow 2 plus x over x minus 2. So we substitute 2.001 and here 2.001 and simplify. We got 2.001 over 0.001. Positive number and positive number. So positive or positive, positive. So the answer is infinity. If it were negative, then it should have minus infinity. So let's find a one-side limit if it exists. So basically it's a limit x arrow minus 2, minus means from the left, x squared over x plus 2. So let's rewrite limit x arrow minus 2 to the minus 1, x squared over x plus 2. Do direct substitution, minus 2 for negative 2 plus 2. So square of negative 2 is 4. This becomes 0. 4 over 0, undefined. So now we have to decide the answer is infinity or minus infinity. So to decide that one, first we need to know x arrow minus 2 to the negative means what? It means that x approaches minus 2 from the left, and x is always less than negative 2. So in this case, you substitute x equals slightly less than negative 2. So x equal to, say, minus 2.001. So limit x arrow minus 2 from the left, x squared over x plus 2. So put this, substitute minus 2.001 and minus 2.001 plus 2. Square the 4, and the top is almost close to 4, and this becomes negative 0.001. The top number is positive, the bottom is negative, so the answer is number less than 0. So therefore the answer to this one is minus infinity.